Hello everyone, I'm Alan Willen. This is a presentation for a tool I wrote for DSU's CSC 842 security tool development. So after working on some of my other tools to include, or in particular, emoji obfuscation, I was trying to think of other ways that someone might hide data in plain sight. And so I was thinking through different things people tend to do on social media and online to include like watching videos and posting images and whatnot. And I was thinking about the GIF format and whether or not we could either adjust the individual frames or put data in there. So I went through the specification for GIF 98A, which is the newer of the two formats. So at this point, GIF has predated the internet and is very widely compatible with essentially anything that views images. GIFs are going to display just fine, and generally with their movement frames. So looking through the specification, I found that there was the way the file was actually structured, there was a series of fields that a viewer would parse through, and it would determine how to render the image. Of particular interest to me that there was a particular field, the comment extension, that someone could include any number of, as long as they didn't impact the wider data stream, and that they were encoded in 7-bit ASCII. So to get around that, or essentially to conform to that, in addition to zipping and encrypting our data, we're also base64 encoding. So this time we are not base64 encoding it because it's fun to do. In this case, it's a requirement of being able to slide our data into the file. So what my tool does is allows you to take either arbitrary text or arbitrary data. It'll zip and encrypt it, AES encrypt it, and insert it into a random spot into the file. So it is, when I say random spot, I mean it is moving aside the valid extensions on either side and putting our equally valid, but in this case, obfuscated information into the file. So I've tested it on a few websites and I found that the data doesn't get displayed. I'm sure that there exists some parsers for it somewhere, but I imagine it's probably relatively esoteric and not very likely to be observed. Interesting thing about GIFs is they actually tend to be quite large because it's a lossless format. So in just grabbing a couple that I actually tend to use on Discord, I found that they range anywhere from half a meg to more than 10 megs. Giphy, which is actually the website that I pulled the test GIF that we're going to use for today, I believe has an upper limit of 10 megs. So here's our local file that we will be playing with. So to start off, we are going to just include a basic message. And output it to a new file. So this preserves the original. So depending on the size of the file, it can take a while to parse. In this case, in our case, the original file is only 1.1 meg, so it parsed relatively fast on this Kali image. So we are using just a garbage key. The tool allows you to randomize the key or specify a key in IV. As I always like to do, we MD5 the original GIF itself, the data, our zip of the data, our base64 in data. In this case, obviously, we're ballooning since we're starting at 14 bytes because it's just simple ASCII, and then we're zipping it and base64ing it and encrypting it and whatever. So it becomes much larger than strictly necessary. However, for just interoperability to make it easy, it does these same steps regardless of the amount of data that you're putting in. So in this case, we are inserting the data specifically at offset 715, 755. The offset's chosen at random. And we get the MD5 of the output. So we can take a look at the data. That we've encoded. So in this case, again, it has to reparse the file because it has to parse it every time. It is going to go through the entirety of the file looking for any comment extension data. So in this case, it found our offset and decrypted it successfully. An interesting thing about this is because the file format allows any number of comment extensions, that we can actually insert multiple files or multiple strings, and we could even use different keys if we wanted, because they're, in this case, they're essentially all independent as they are being inserted in random spots. So in this case, I just went ahead and grabbed a binary, just the NSLOOKUP binary. In this case, we do have gains because the original size zips well, and then we base64 encode it. This time we're inserting at offset 115 to 816, and I just overwrote the GIF that we already had for our convenience. So we'll do a decode. In this case, we get this giant awful output because we're just splitting it to screen. So you see that we have two different comments at two different offsets. So our one that we inserted the second time and the one we inserted the first time. In this case, it's just outputting them to screen. Alternatively, we can extract them. So in this case, it doesn't know what file type it is because it's not looking at any magic bytes or trying to interpret it as a string or anything. It just took the original file name and prepended the offset in the file that we were looking at. So that's our string message, and then this other one should be our ELF binary. And there we are, ELF. So in playing around with this, another thing I thought was interesting to do was to actually remove comments. So in cases where I've either found that someone else hasn't made a comment, or I want to get the original image back to clean it and then use it again. I have to fix the code because I apparently forgot to copy and paste the code, the IV and key in a couple places. But what will be on the GitHub is that it goes through and it finds every place that there is a comment and removes those from the output file. And so in testing, I've been able to successfully recover the original MD5, or a file of the same MD5 as the original. And then for a final test or final show off, so here's our modified version. It looks the same because we only have modified the underlying file format and inserted some text where the parsers expect there to be text. Just in our case, it's a series of base64 encoded blobs. So this conforms to the spec. It properly splits the data up in 255 character increments, which are the size of the individual data buffers. We can have any number of data buffers, so regardless of the size of the original GIF, even if it's 10K, we can insert an arbitrary amount of data, 10 megs, if we really wanted to. It's just a matter of what would look good for whatever you're doing. So I hope you find this interesting, aside from the one bug, obviously. I thought it was an interesting pivot from the emoji obfuscation, since it's another way to, again, pass data in plain sight. Although in this case, if someone knows that this data might exist, I imagine there's not many things that put comments into GIFs, so it would be relatively obvious that something weird's going on. But considering how often people share GIFs, and you'd have to have a list of all valid GIFs to do a quick MD5 check, where you'd have to like manually parse or write a parser for it to find strings, and then it's a matter of like whether or not you're even able to retrieve the encoded data. So I hope you enjoyed that. Thank you very much.